welcome students to one more session of your hydrocarbons chapter. So gradually, we've been doing different topics. We've studied about alkenes, we've studied about the preparations of alkenes, and chemical properties of alkenes. Then I went to next topic, that is alkenes. There also I've taught you the structure, hybridization, preparations, isn't it? Last topic was Linder's catalyst, that is hydrogenation reaction. Now today we'll be starting with the chemical properties of alkenes. So basically, whenever I speak about alkenes, what is the first important thing you have to remember? In an alkene, basically when I take, alkenes are double bonded compounds, isn't it? Right? So when I take an alkene, it's a C double bond C, isn't it? Right. So up around alkene, we have the tetravalent. So 1, 2, 3 and 4. 1, 2, 3 and 4. Done. Here, when I have to speak about alkene, what types of bonds are there? One bond which is there is a sigma bond, which is present in alkene, and the other bond which is here is a pi bond, isn't it? Yes. Now, so whenever you're trying to show a chemical reaction, done. So suppose let me take, there is one reactant A, B, okay. This is going to combine with this. What will happen? The reaction, or first important thing, sigma bond is stronger than pi bond. So what will happen? There is a cleavage of this pi bond, and this also there is a cleavage of the bond here. One A or this one goes in, one reactant reacts here, and one of the one of the atom comes and reacts here. How does it look? It becomes C, single bond C, because the bond is broken. Here again, this is the bond where you get A and you get B. This is how the alkene is reacting. So based on this types of reactions, so the types of different types of reactions, or the characteristic reactions which alkene shows are the most important reactions, is it is going to show as addition reactions. So because of the presence of double bond, so addition reactions it's going to show. After that, alkenes are also going to show as substitution reactions, that is allylic substitution reactions, that we will be learning. And after substitution reactions, it is also going to show as oxidation reactions. Done. So alkene also shows oxidation, very important reactions of alkenes, which we'll be studying under using oxidizing agents under K-4. After oxidation, it's going to show as polymerization reaction, where one alkene molecule forms a number of chains. It's going to form chain like polythene, polyester, polyvinyl chloride, like that. Okay, let us not waste the time. Let us further go to the reactions. Now I'll be starting with the first type of reaction, addition reactions. So in addition reactions, when I take, okay, let us start naming that. So first of all, addition, what type of addition reaction does it undergo? So whenever I take alkene or this one, the double bonded C double bonded alkene, it's going to show addition reactions of type what? Here I'll be teaching addition reactions for both types of alkenes. That means I'll pick up both symmetrical alkene and I'll be showing unsymmetrical alkene also. Okay, what is symmetrical alkene? Let us see. So symmetrical alkene, that means it is C double bond C. Okay, so in symmetrical alkene, what are you observing here? Okay, this is only single bond, isn't it? 1, 2, 3 first, 1, 2, right? Symmetrical alkene means when I take the double bond, on either side you have equal number of carbon atoms. That is symmetrical alkene. Suppose here if I take 1, 2, 3. Now suppose if I break the double bond, here how many carbons are there? 2. Here how many are there? 1. So if they have unsymmetrical carbon atoms on either side, it is called unsymmetrical carbon atom. Here 1 is to 1, but here it is 2 is to 1. So this is unsymmetrical alkene. Done. Now next important thing. And these, I'm going to show you the different types of reactions. What are the different types of reactions it's going to show? See, in addition reactions, we'll be learning how does the hydrogen add around both. So these are common reactions of both. I'll show you how hydrogen is added. I'll be showing you how you're going to add this one, HCl to this. Yes, I'll be showing you how we'll be adding halogen to this. X here can be bromine. Yes. I'll be picking up bromine and showing you the reactions. And after that, after hydrogen, after HCl, after HX, because of the double bond, I'll also be showing you how you are going to add sulfuric acid to this. You'll be studying all this. We'll also be learning how to add water to this. Like addition of water. We will also see how alcohols are formed, because how should I break? The procedure is the same as I showed you earlier. Then I'll be showing you how are you going to add HOCl to this. What is HOCl? It is called hypochlorous acid. Hypochlorous acid, right, students? So let's start with the addition of hydrogen. One after the other we'll be noting, and we'll be seeing how should I add the hydrogen around the double bond, how should I add HCl around the double bond, a halogen around the double bond, sulfuric acid around the double bond, water around the double bond, and HOCl in the double bond, right? So first of all, let us start with the first type of addition. I said both symmetrical and unsymmetrical alkene we'll try, right? Now the first example which we're going to learn is how to add hydrogen, addition of hydrogen, the simple basic hydrogen I'm going to take. Your teacher also may be giving you hydrogen or H2 dihydrogen, right? So first of all, whenever I take an alkene, I said we'll be doing with both symmetrical and unsymmetrical, right? So let us first take and divide the page into 2 equal halves. Okay, I have my scale. Let me divide into 2 equal halves. Now, first of all, I'm going to take a symmetrical alkene here, as I showed you, and I'm going to take an unsymmetrical alkene here, which I showed you. Symmetrical alkene is C double bond C, equal number of carbons on both sides. Done. So fill in hydrogens, CH2, CH2. What is the name of this compound? This is called ethene, because there are two carbons. Now I'm going to add hydrogen to this. Here unsymmetrical alkene, I'm going to take propene, 1, 2, double bond 3, fill in hydrogens. This carbon has already 1 bond, so this becomes CH3. This has 1, 2, 3 and 1 H. This has 2, 1, 2, 2. Total should be around carbon 4 hydrogens. 3 plus 1, 4. 1, 2, 3, 4. 2 plus 2, 4. Done. So here I'm going to again add what now? I'm going to add hydrogen to this. Right. So here in this case, when I take hydrogen, because it's going to break and add there only, isn't it? Right. Let us see this. How we are going to add. Now, whenever you are adding hydrogen to this, the most important thing we should remember, you need to have a catalyst. Okay, because why? Addition of hydrogen, that is, reduction. Reduction always requires a reducing agent, isn't it? So, the catalyst which I'm going to use here is finely divided nickel, means powdered nickel, or it can be platinum, or it can be palladium. So, that's why you're adding in the presence of a catalyst, the reducing agent, which hence we call this addition of hydrogen as catalytic hydrogenation. Catalytic hydrogenation, addition of this one. So let us write the heading as catalytic hydrogenation reaction. Okay, hydrogenation reaction. Done. So here catalytic hydrogenation reaction, what will happen? There's a bond broken here. What do I get? I'm going to get CH3. Okay, now this bond is broken. One hydrogen goes and adds here. One more hydrogen comes and adds here. CH3 single bond CH3. What is the name of this compound? This is ethane. Okay, right. So next, suppose if I break here, how should I break? I'm going to break. One will add around the double bond, one more will add here. So I get CH3 single bond CH2 single bond CH3. So this is propane. Simple. I've just added around the double bond. So this process is called catalytic hydrogenation. So in grade 10 we also studied, isn't it? It is used like hydrogenation reaction for preparation or manufacture of manufacture of vanaspati ghee, the what do you say, unsaturated vegetable oil to saturated one, means we have prepared it from vegetable oils, isn't it? So this process, basically hydrogenation, we are converting vegetable oils into vanaspati ghee. This is the vanaspati ghee. This is the procedure. Okay, done. So simple hydrogenation we did. Now we are going to see how are we going to add halogen to this. Let us turn the page and see. So now I am going to write the heading addition of halogens. Okay, addition of halogens. Fine. So when I take addition of halogens, halogen is denoted by which one? X. X can be here. I am going to take bromine. Done. So you can also add chlorine also. Fluorine, okay, high electron is not possible. So you can add chlorine also, chlorine, bromine, right? So now, suppose if I take both, let us again divide the page into 2 equal halves. So I'm going to divide the page into 2 equal halves, and where I'm going to take one symmetrical alkene, that is CH2, double bond CH2, and one more unsymmetrical alkene, CH3, single bond CH, double bond CH2. Now what am I going to do? I'm going to add to this bromine. Here also I'm going to add, here what did I do? I picked a bromine. Here also you're going to add bromine. So both, this also, this presence. Now we are going to take an solvent for this. What is the role? What is the use of this? I'm going to take an inert solvent. So carbon tetrachloride is an inert solvent, so that it does not react, means that particular thing, it easily forms the product. It's inert. Its role is nothing to react with the reactants. Done. So what happens in the presence of this Br2, as I said, how is this Br2? It is basically bromine and bromine, isn't it? There is a cleavage of the bond here. Here also there is a cleavage. One bromine goes and adds here. One more bromine comes and adds here. Okay. Yes. Now here also the same condition. Br and Br, there is a cleavage. One bromine comes and adds here. The other bromine comes and adds here. What do I get? What product do I get? I get now one bromine. This is carbon. I have written this carbon, isn't it? So that CH2 is there only, isn't it? No change, CH2. So Br has come and add. Now double bond has become single bond. CH2, Br has come and added here. Now in this case, this CH3 is here, CH3. Then this CH is here. But there's one bromine which is added, Br, single bond. CH2, yes, the bond has broken. So CH2, then one more Br comes and adds here. Over, isn't it? No, that is right. What is the name of this compound? Here we have two ethyl groups. Okay, right? That is ethene basically. So where are the positions? This is 1 and this is 2. Now name the compound. This is 1, 2. Okay, 1, 2 dibromo ethane, isn't it? 1, 2 dibromoethane. Now let us name this compound. When I name this compound, again, this is 1, this is 2, 3. We already know it should get the minimum number. So name it 1, 2 dibromo. How many carbons? 3 carbons. So it is propane, isn't it? Done. Fine. So now what will happen? We very well know, like whenever you are adding bromine, this is basically bromine test, isn't it? This wherever you have double bond, we add this bromine in the presence of inert solvent. So this basically is a test for unsaturation. We said whenever you're using bromine in the lab also, we said test for unsaturation. How do we know that this is unsaturation is present or not? What happens is whenever you are adding bromine solution, right? So what is the color of that? The reddish orange color, isn't it, of this bromine? This reddish orange color of bromine is discharged out. And whenever you are adding that bromine to this, whatever color you have, whenever there is double bond, whenever there is unsaturation here, that reddish brown color or reddish orange color, everything is discharged out and it becomes colorless. So this will give the test for unsaturation. So bromine water test is always test for unsaturation. So it will clearly tell whether the compound given to us is unsaturated or not. Unsaturated means double bond and triple bond, isn't it? Fine. So it's going to tell us whether the compound given to us is unsaturated or not. So this is your bromine water test. Careful. So orange red solution will wane out or fade out, saying that or indicating that it is means the given compound is unsaturated compound or not. Now that is also over. Now let's see next example. What did I say? After that, after addition of hydrogen halogen, now we'll come back to the next important example, that is addition of halogen acids. The third important example is addition of halogen acids, right? Halogen acids, right? So when I take addition of halogen acids, nothing. Halogen acids means halogen is present together with an H plus ion. Acid is nothing but which has H plus ion. So example is, you're just adding HCl to this, halogen acids. Or it can be HBr, okay. It can be hydrobromic acid, it can be HI also, right. Whenever you are reacting, okay, whenever you're taking either this, first of all you should know the order. What is the order? Which will react faster among this? HI, right? HI reactivity is greater than HBr reactivity is greater than HCl, right? Right. So here, whenever I take the example, now I have to show you the example. How are they going to add around alkene? Correct? Right. So suppose if I take a symmetrical alkene, let me say, take one example. Now I'm going to take a symmetrical alkene, CH2, double what? CH2. Now I'm going to add HCl. Let me take HCl. So, like any example, what order is this? But I've picked up HCl. So as soon as this is done, there's a cleavage of the bond here. There's a cleavage of the bond here. Now what will happen? This hydrogen goes and adds to this carbon, and this chlorine adds to this carbon. Now what product do I get? I'm going to get CH2 will become, adding this hydrogen become CH3. This will become CH2Cl. What is the name of this compound? Name it 1, 2. So this is chloroethane. Chloroethane. Done. Yes. Now not a problem. Simple it is. Now the problem starts when you start adding halogen acids to an unsymmetrical compound. This is where you have to be careful. Right? So now in case of an alkene, like when you have an unsymmetrical alkene, for example, unsymmetrical I showed you 1, 2, 3. This is unsymmetrical alkene. Right? Now let us fill the hydrogens. 3 hydrogens. Here 1, 2, 3, 4, 1, 2, 2. What is the name of this compound? This is nothing but propene. Now to this propene molecule, right? Suppose if I have to add unsymmetrical alkene, I have to add the halogen acid. Let me take HBr, right? So now, sorry. Now what will happen? Here I'm going to provide, or first take the condition. What condition is this? Here the reaction or this unsymmetrical alkene, okay, it occurs in the presence of, or it is the reaction between propene and HBr. This one is occurring in the present in dark, right? And we are not going to take any, means basically we study unsymmetrical alkene in the presence of peroxides, with peroxides and without peroxides. Okay, ma'am, what is this peroxide now? Without peroxide also we'll learn. So there are two conditions. One, I'm going to take the same alkene with HBr and with dark. Okay, now no peroxide. One more example. I'm going to take one more unsymmetrical alkene with CH3, CH double bond CH2, HBr. Now what am I going to do? I'm going to take the reaction forward in the presence of peroxide. Remember, both the conditions, both are propenes only, right? Now, suppose when I take this propene in the presence of no peroxide and in the presence of peroxide, what products we get? We will see. Right. So here the main concept, a Russian chemist, okay, Markovnikov. So Markovnikov, spelling M-A-R-K, Markovnikov's. Markovnikov's rule came into existence for studying unsymmetrical alkene addition to halogen acids. When did he take this? In 1869, he has framed a formula, that is a rule called Markovnikov rule. He was a Russian chemist. He has framed this rule called Markovnikov rule. First we will see the product and start defining. So here what happens whenever HBr is there, there is a cleavage of the bond here, that is only the pi bond. There is also a cleavage of the bond. Here when it comes, there is a cleavage of the pi bond. I should not write this, only the pi bond. Again there is a cleavage of HBr. Now what happens? In the presence, in the absence of peroxide, it's going to show two different products. First what will happen? Yes, just see here. Two products are formed. In the first case, or in the major product, this is H plus, this is minus. This is H plus, this is minus. So in the first case, the negative part, once again, this is positive, this is negative. The negative part or the negative addendum goes and adds to the carbon having lesser number of hydrogens, right? So what does it do? It will go and add to the carbon having lesser number of hydrogens. So around double bond which has lesser number, this is one hydrogen, this is two hydrogens. So this is lesser number of hydrogens, this one. Right, in the next case, fine. So it's going to add like that. What product do I get? I get CH3, single bond, CH, this is Br, this is CH3. Okay, because bromine and add here, hydrogen is going and adding here. And then one more. In the next case, here you will have the negative part adding to the carbon. Now first case this is over. In the next part what will happen? The negative part goes and adds to the carbon having more number of hydrogens, this one. Initially less number of hydrogens, this one. Second, more number of hydrogens, this one. So what do I get? I get CH3, CH2, CH2, Br. This is the thing. Now hydrogens added to this. So what is the name of this compound? This is 2-bromopropane. Why did I write this 2-bromopropane? Because 2-bromopropane, 3 carbon. Now what is the name of this compound? This is 1-bromopropane. 1-bromopropane. Now when I see both the things, okay, That too in the dark without peroxide. The major product is 2-bromopropane. Remember that. So what do we get after addition? We are going to get right. So what is the name of this compound? This is called 2-bromopropane, isn't it? So 2-bromo. Why did I write 2-bromo? Because 1, 2 or either side, whichever side you count, it is 2-bromo. 3 carbons are propane. Now next, after this, I said here negative part adds to the carbon having lesser number of hydrogens. So first condition is negative adds to lesser number of the carbon having less number of carbon hydrogens. Okay, less number of hydrogens. Remember that. So here this has 1 hydrogen, here this is 1 hydrogen, this is 2 hydrogen. Just remember. Now next important thing, here in the second case negative adds to the carbon having more number of hydrogens. So here we get CH3, CH single bond, this is 2, and you get CH2Br. Right, this is 1-bromopropane, 1-bromopropane. So now what happens here, the negative part adds the carbon having more number of hydrogens. But what is major among these two when I compare both? This is the major product. This is 90%. 2-bromopropane is 90% of the product, and here 10% is 1-bromopropane. So what is the first important thing you have to remember? In according to Markovnikov rule, whenever you take an unsymmetrical alkene and when you add HBr, and that too in the presence of it is dark and there is no peroxide, you get 2-bromopropane as a major product. 1-bromopropane is a minor product. Done. Now suppose if I take the next one, next condition, this is condition 1, next condition is condition 2. Now again I am taking unsymmetrical alkene, but here I am going to add same thing again, I am going to add HBr, but now I am going to take peroxides. Important thing is peroxides. So here organic peroxides, so it can be benzoyl peroxide, right? Just like that. I am going to take peroxide. When I take peroxide, what will happen? There is a cleavage of bond here, positive and negative. In this case, in the presence of peroxide, the negative addendum adds to the carbon having, just see, you have double bonds, isn't it? Now, opposite to this, negative addendum adds to the carbon having more number of hydrogens. So here, when it adds more number of hydrogens, what do you get? You get CH3, CH2, single bond, CH2Br. Now, this is, what is the name of this compound? This is 1-bromopropane. Okay, now 1-bromopropane is a major product which we get. Now this rule where you take an unsymmetrical alkene, you add HBr in the presence of a peroxide, this is called anti-Markovnikov's rule. Okay, anti-Markovnikov addition. So anti-Markovnikov addition. Okay, now let me summarize what I said just now. Let us take a page which has line already. So what should you remember? You have to remember in Markovnikov, Markovnikov, Markovnikov addition. Okay, and next important thing you have to remember in anti-Markovnikov addition. So first important addition. Okay, I'm not writing the full form. So in Markovnikov addition, do we require a peroxide? No peroxide. Here in anti-Markovnikov addition, yes, peroxide, in the presence of peroxide. This reaction occurs in dark, isn't it? Wait, sorry, a little bit, no, uneasiness. Okay, fine. So this reaction occurs in dark. This we said only in the presence of peroxide. Now next important thing, what are we going to take here? We are going to take unsymmetrical alkene. Here also we are going to take unsymmetrical alkene. Here what is the major product which we get? You get 2-bromopropane because you have taken, this is a major product. Here what is the major product? The major product is 1-bromopropane. 1-bromopropane. Okay, this is a major product. So remember this. This is, if you remember any type, anything given to you, answer. Any Markovnikov reaction is given to you, you can easily write. So according to Markovnikov, 2-bromo is major. According to anti-Markovnikov, 1-bromo is major. Now we are going to, in my next video, I'll teach you what is the mechanism of, or how should you do Marconic of addition and anti-Marconic of addition with the mechanism clearly. Thank you for watching, students. Let's meet again in the next video. The most important part of alkenes, Marconic of addition reactions.